If you need something, holler.
Okay.
Thank you very much.
Thank you. Yeah, students over here, I'm this way, obviously, that's the whole. Oh, yeah. That's good. That was good. How you doing?
Morning. Everybody here. Oh, morning. Luke. Morning, everybody.
I'm Bill Bell from Kentucky Engineering Center. Laura Bowler is on her way. She was supposed to be moderating this morning in the next session. She got stuck in traffic. So, and I guess people still don't know how to drive the rain. I don't know. Okay. Just a little announcement before we get started. Remind everybody, or this is a reminder to everybody, download the Crowd Compass app. That will tell you where the sessions are, and then also allow you to do evaluations after each session, which will then put your name into the pot for a door prize drawing tonight. So you can enter, the more evaluations you do, the more time your name gets in the pot. So, and the Crowd Compass app, the password is partnering 2021. If anybody has any issues, just come to the registration desk and we can help you out. Okay, this session is the Brent Spence Bridge Emergency Repair. And we have Jason Stith and Josh Rogers here. Jason is a bridge technical manager with Michael Baker's Louisville office. He was Michael Baker's project manager for the Brent Spence fire rehabilitation. Josh Rogers is with KYTC. I'm not going to go into your full bio because it's like 2 pages. So, but I will say all the bios are on the app as well. But Josh became the director of maintenance, where he's focusing his efforts on pavement and bridge operations, as well as various other programs within the division. Please welcome these gentlemen. Thank you very much.
Well, so yeah, we're here to talk about the Brent Spence fire. I'm sure a lot of you probably already heard about this incident, but we'll try to bring a few more things to the table, a little bit more technical than we're trying to do here today. I'm gonna see if this thing works. No, I keep telling everybody the older I get, technology is leaving me behind. There, thank you. So you young guys know how to do it. So yeah, we're just going to introduce the project a little bit. Of course, this was a pretty big bridge emergency. I will say, KYTC, this bridge did get a lot of attention, but it's nothing out of the norm that we deal with every day in and out, putting out fires. This one was so this emergency inspection, we're going to focus on the inspection and the design, the consequences of the fire at a bridge, especially post-fire inspection, what we learned, and then how do you get it done. A little history on the bridge. This is I-75 over the Ohio River between Covington and Cincinnati. Opened in 1963, November. It is a steel cantilever truss with riveted construction, 4 lanes of traffic, top and bottom deck, carries about 160,000 vehicles a day. It is a big infrastructure for probably the whole eastern United States. So, pretty special bridge. So, the fire limits, we focused mainly on 4 to 5 panel points. Instance limits on the upper deck were between around L16 prime and L20 prime, as well as the lower deck as well. So that just shows you a typical elevation view of the bridge, top and bottom deck. There's a little elevation view of the bridge. We did utilize UAS inspections during this, which was very, very beneficial. Here's a little typical section, full beam, top and bottom deck. About 49 feet out on the deck. And like I said, it's 4 lanes. Try to see it. There.
Hey there, homeowner. I was like, you never lose.
Bear with us here, we got a little video.
Got a call about 3:15 in the morning. And those are the kinds of calls you never want. Nothing ever good comes up at 3:15. My truck's caught on fire. You're gonna have to come, my trucks are gonna have to come southbound going northbound, because the truck's on fire on the bridge. There, a crash on the Brent Spence Bridge. There was a major fire, and they did not know the extent. I walked back in and turned on the light and told my wife that the Brent Spence Bridge was on fire. I had to go to work.
Part of the Brent Spence Bridge burned overnight. Now crews are trying to clean up the mess and drivers are dealing with the traffic pattern.
The I-71, I-75 corridor is part of the lifeblood of commerce. So we knew when this crash occurred, we had to act quickly.
When the governor and I spoke on Wednesday before the press conference, he said, Jim, we want to get this job done and we want to get it done quickly, but it's got to be done safely. And that became a touchstone for the entire project.
The scars from this morning's crash and fire on the northbound lanes of the Brent Spence Bridge will likely remain visible for a long time. It's what those scars tell inspectors that will determine just how long the bridge will have to remain closed.
I called in about 20 to 30 bridge inspection personnel. The fire damage was constrained to a certain area, but having that many personnel and qualified personnel, that led us to a quick turnaround to get that inspection done and performed and see what actually was damaged and what needed to be fixed.
The main truss members were far enough away from the fire or shielded by the concrete. Concrete's an excellent insulator and greatly reduces the amount of heat, that's going through. That's why the lower deck, while it was a location of fire, actually had less damage and had less work and repairs that had to be done. The upper deck, which was directly above the fire, was not insulated by the concrete deck, and all that fire got into those. The damage to the upper deck was to the stringers, the metal beams that run under the concrete deck. They were warped and it caused the upper deck to actually be displaced.
We sourced these steel beams from 4 different mills in the country. The contractors visited the site to examine the site on Saturday and Sunday, and they gave us a price on Monday morning.
Right now, the other bridges are having to shoulder the load that Brent Spence Bridge usually handles.
The traffic control is a major part of a project. If this were a scheduled project, that we were going to replace a portion of the deck on a Brent Spence Bridge, we would have taken months to determine the traffic patterns. We had hours. We had contacted Bob Yeager, our chief district engineer from the state highway department, and he helped us coordinate state resources to get out there with directional signage, crash trucks, and he came out there and helped us facilitate the detour around the 275, 471 corridor. I actually say there were 3 projects in my mind. There was the bridge inspection and repair project. There was the traffic maintenance project, and there was the communication project.
My role was to kind of oversee all 3 of those and make sure that information was shared not only among, but between each of the groups so that we could coordinate them.
The Brent Spence Bridge is such a nationally prevalent bridge, there were people even beyond the local area that needed to know what was going on. We established a dedicated website and made an effort to put out consistent visual content so that people would know what exactly was happening on the bridge. They could track along with us, and they needed to know how else to keep crossing the Ohio River.
It wasn't a complex project, but the conditions were complex. The removal of roughly 8,000 square feet of concrete, removal of these steel beams, the replacement of them, the replacement of the barrier walls, but it was under a very constrained, very demanding schedule on a tough site.
Throughout the construction process, a lot of people that are saying, well, I'm never gonna drive across that bridge, I didn't trust it before, I'm not gonna trust it now. I think if the structural integrity of that bridge was ever proven during this event, because they went in and basically surgically removed the damaged portion of the upper deck of that bridge, and the rest of the structure remained intact and stood there. It was very obviously very structurally sound. What impressed me the most was the expediency and the effort and the cooperation that we got at all levels. Working with two states, they try to get something done would typically take, at least a few conversations. Everybody was on board, not asking why, but how. How can I help?
The plans for the Brent Spence are not to remove the current Brent Spence, but to build a companion bridge to the west. It needs some relief, but it's really a capacity issue.
We were surprised by the response that we got opening day. People really appreciated the work that was done. It was more than just getting the bridge back open, but I think they really appreciated the people and the sacrifice that it took to get it open early and that it was going to be safe.
Thinking about all of the things that we were able to accomplish in 6 weeks, all of that's kind of replaying in your mind as you drive through it. Like I said, just a relief that this is real. Like it really happened. We were able to get accomplished and pride.
This project on one of the most important arteries of transportation in America, we came through under budget and ahead of schedule.
Felt good to watch other people drive over it, really. I mean, that was when we finally felt like we accomplished something, when everybody just started driving over it like nothing had ever happened. I'll remember this my entire career. Yeah, it's the Brent Spence Bridge, so you remember that.
Kentucky homeowners, there are 2 ways you can get paid to go solar this year with our new solar program for 2021. The first is that you'll receive a
Thanks. So that was a 6-minute general overview of what happened, how we got there, open it back up. We're going to dig into a little bit more of some of these other areas. Yeah, we ended up putting this all together, with such a quick turnaround for what we needed to do. There was things going on simultaneously. So, it was multiple activities had to occur at the same time, going around the same path. So this pretty little neat diagrams could share quite a bit. We had the public awareness and inspections, and design, construction, even the procurement, and then the maintenance of traffic. So it all had, it wasn't a traditional linear approach from like a design bid build project. So we was looking at this at several different angles. So yeah, the initial incident was on Veterans Day, November 11th. I'll give them that just here in a minute. Had a letting Monday, November 16th. So within 5 days, we turned around the inspection, repairs. It was a really fast approach. So, initial impressions. I got a call around 8:30 Veterans Day morning. Nick Rice, our District 6 Bridges here, called me. He says, "Josh, you seen the news?" I said, Nick, it's Veterans Day, I'm not watching the news. So, he said, well, the Brent Spence is on fire. I said, well, how bad is it? He goes, you may want to get up there. So, I got up there about 9:30, of course, we being in Home County. And, it was a mess. I mean, we had two jackknife trucks, semi-trucks, that collided or jackknifed on the bridge, caught on fire. Lower deck was damaged, of course, we expected replacement. Significant removal was required of that debris. It took a whole day to get all that debris out. I mean, the smell alone, Jason can remind me of this too, you know, it's just that smell, it was horrible. I mean, it's just burnt tires, burnt metal. I don't even remember what they was carrying then, it wasn't much, but it took forever to get this deck cleaned. So, it took all that first day, Veterans Day. And it even went into the night to get that deck cleaned, get all that debris moved, so we could even start the inspection. So yeah, I think that actual night, you know, we sat around late at night trying to work up how we're gonna tackle this thing. I actually called Michael Baker. We all sat, I don't know, some restaurant that night, and we got down and started planning and what we'd have to do. So, we knew this wasn't an emergency inspection, but it wasn't the same as a typical special inspection or fracture critical inspection. So, several factors that came to my mind was, you know, priority one is the safety. You know, it's safe for pedestrians, it's safe for us to even be on the deck to inspect, and let alone safe for traffic to cross it. So, priority two, of course, was taking those inspection results and what needed to be repaired, replaced, fixed. And like I said, late night that night, we just grabbed some napkins and pen and started writing some stuff down. So, HAZ, that was a hazard affected zone, what we determined that acronym to be. Of course, we knew that we had a pretty good location of where the fire was. So that was our main concern for it there, was looking at those fire limits. But of course, you know, the upper deck, lower deck, looking for typical concrete deterioration, laminations, cracks in concrete. Floor beams, of course, primary structural members was a big concern. The stringers and the truss members, of course, there's pin hangers on this bridge, and of course, even the finger joints. L17 prime was right at the suspended span, right at the finger joint. So our priority list, like I mentioned, we wanted to make sure the bridge was structurally sound, not only for pedestrians, us being on the deck to inspect and do our work, but also navigation traffic. You know, we shut down navigation traffic because we didn't know if this bridge was going to fall within 10 minutes or it wasn't going to fall. So navigation traffic was shut down. Of course, vehicular traffic was our big concern as well, and the extent of the repairs. Talk a little bit about what it took to get this done so fast from an inspection side. So when I got there on Veterans Day, I was already thinking, I said, this is going to be a challenge to get this actually inspected and find the results that we need to move forward to replace and fix. Big shout out to all the consultants I called. You know, it was Burgess and Nyepel, Palmer was there, of course, Michael Baker, Stantec. I think at one point we had about 20 bridge inspectors on site on this bridge from end to end. So looking at, you know, it was a special emergency inspection. Want to mainly focus on that heat affected zone, but also we knew that, hey, it wouldn't hurt to look at this whole bridge since we didn't know what else was going on with it. So had 4 teams of 2 inspectors, looking at the lower cord, the upper cord, of course, looking at movement of bearings and wind locks, anything that could have been affected from this fire. Of course, we started at the end and worked toward that panel point 17. We knew that truck was. Like I said, we developed and organized inspection teams and packets. Every morning I met with all the team leaders at 8 o'clock just to go over previous day results. I tell you, during the whole day, I was on the phone and trying to manage all the inspection teams, and I was talking to upper management. Bob he was in on all those conversations, and we was always talking to management, saying, hey, here's what's going on, and it went really fast. So that initial day, we got out of the bridge at 9 o'clock and started inspection. So from the inspection standpoint, of course, what was we looking for? Paint showing from the heat, from the fire, concrete, buckle members, and of course, joints, bearings, and wind locks, and that kind of stuff. So primarily a visual inspection, but then we did incorporate material testing that we'll get into here in a bit. So we did obtain steel core coupons, concrete cores of the deck within the heat affected zone, and also non-destructive testing at additional locations within the heat affected zone, and also kind of control samples outside the heat affected zone. We took core samples of steel and concrete to kind of get a baseline of what that was. I think Jason will get in that here a little bit. So yeah, lower deck, we took 6 cores. That kind of assisted us in defining what the limits of that heat affected zone was. But it also helped us determine the depth of the overlay, location of the steel in the deck. And one of the lessons learned from those concrete cores, we took cores right down the center line, and looking back, we probably would have wanted to take some along the gutter line, because that overlay thickness, of course, did change toward that gutter line. It wasn't a constant thickness. So concrete deck and the lower deck was not compromised, even though it looked like crap. It pretty much, the fire pretty much just peeled up the overlay. So we knew the lower deck was pretty good shape. The upper deck didn't turn out to be that case. We took 8 cores again along the center line to test for those compression strengths. That assisted in defining those repairs, determine the depth. The upper deck was heavily damaged. I remember like day 2, we was out there, maybe day 1, I can't remember. They still washing off the top of the deck to kind of remove all the debris. The emergency services, fire department. And it sounded like, it even looked like rain coming down through the deck. I mean, water was just percolating right through the deck. I mean, it looked like a thunderstorm coming through there. So we knew that upper deck was compromised. I mean, it was just water pouring right through. So it was heavily damaged, and we knew it had to be replaced. Here's just a few pictures. We did utilize a lot of rope access on this, just because mainly we did not know if we could get inspection vehicles, man lift snoopers even on this bridge. So a lot of rope access was utilized. You can tell that at the top left corner. The bottom left, we're taking core samples of the deck. And then some of these other pictures with the, I call it the spiders, that picture in the middle. It looks like a little spider man lift. It's pretty neat. It only weighed like 4,000 or 5,000 pounds, something like that. So it is pretty small. And then 2 pictures, we did utilize our 875 snooper, but we put it actually behind panel point 17, just because we didn't know if that sheer weight of that machine. So we just extended the boom to help us get access. And then of course we also had the district's maintenance bucket truck there in the top right. So I think some of those may even be tested, some of the steel. Of course, concern was the fire and what it did to the steel, what it did to the concrete, what the strength of that steel came out to be, or what it was after that. Of course, we knew that there was a rapid decrease in that yield strength depending on how hot that fire got. And of course, the inability to carry the dead loads at elevated temperatures. Quenching of the steel was our biggest concern, because we did not want that to form arsenite, which makes that steel really brittle. And of course, once it gets brittle, it can crack like glass. So that was our biggest concern. And there is an NCHRP 1285. So yeah, fire concern again. What's the source? What's the temperature? How long did it happen? And where's it at? You know, proximity. And this is one of the fires that happened on I-85 actually collapsed one of the spans right there. So, depending on the duration of the fire and how hot it gets, it can be a big issue. So after looking, after we did our inspection, we did some metallurgy analysis, took those steel core samples. Luckily, we did not see no change in steel properties because of the fire. Looks like it did get below about 1,200 degrees. So that's a maximum reduction in strength, 10% for hotter fires. And then we could reuse if distortion's not too severe with a 90% of yield strength. This is just a little PennDOT study we wanted to add in here. You know, it talks about the effects of fire damage on bridge steel. Several pictures there before the fire, the bottom left corner. After the fire, that second to the left at 800 degrees. And then washing the surface, brushing the surface there is also included. So it's a pretty good guide for post-fire inspection. So all in all, after our inspection, you know, the bridge, prior to the incident, we had it all in 5 on the deck super and sub. But we knew there were still some issues with that steel because, you know, it was a fire, it still got hot. So we ended up taking the deck and super to a 1 unit condition for an MBI rating. And we thought that was pretty fair considering what we were seeing. Of course, we did inspect all the steel members for heat damage, distortion, that kind of stuff. And as I mentioned here, y'all can read that, you know, the inspection access we had, over 20 people, including KYTC and consultants. And it was a big hands-on deck. So one of the things I think that was pretty interesting, even with everybody out there, you know, consultants and KYTC alike, and I think even the public, they knew this was a big deal. Everybody put their heart and soul into it. I mean, put our blood and sweat into it. And this was a big concern, and everybody wanted to get this thing inspected, analyzed, and repaired as fast and safely and efficiently as possible. So it was all hands on deck. So I think I'm going to turn it over to Jason here real quick, and he's going to talk about the investigation.
Thank you, Josh. I appreciate it. Thanks for the introduction there. So like I said, I want to talk a little bit more about some of the inspection and the testing that we did as part of this project. Hopefully, again, some of you may have seen parts of this presentation, maybe learn something new on this one. We did do some both destructive and non-destructive testing of the steel on this. Josh mentioned the formation of martensite. So normally within steel construction and steel manufacturing, right, we can quench steel, which makes it harder, but then we temper the steel, which provides additional ductility. If you go through and only quench steel without the tempering, then you have a much more brittle end result of this. So just because of fire, during the fire event, the yield strength drops, post-fire, that strength will come back, but you may or may not have the same amount of ductility, same material properties. And then there'd be an additional long-term risk to the structure with that. So we did several cores looking for the martensite. We also did a significant amount of non-destructive testing. So the philosophy on that was, if we can go through and take some small samples and understand the properties of those and know what's happening, we can then do non-destructive over a much larger area, not knowing whether we could take the cores at the absolute worst location, but if we could correlate the cores that we did take, the destructive testing to those non-destructive testing over a larger area, we'd have a higher level of confidence. One of the things that we found in doing this was that much of the steel was what they call a man-tin steel. That's a high manganese steel. That additional manganese in the steel increases the carbon equivalent and makes it a higher strength steel. It was a proprietary U.S. steel from the early 60s. It was one of the first 50 KSI steels that came out on the market at that time. So many of the main structural members of the truss and the floor beams were actually out of this man-tin steel and not a lower grade steel. In order to look at that, we did some Brunel hardness testing, again, seeing that we had a change in that hardness, as well as they brought out laser-induced breakdown spectrometer. essentially what that did is you shoot a laser and they can actually give you a readout of the chemical composition of the steel to confirm whether we do have this high manganese in it, and if it actually is this man tin steel. All of that was confirmed. So it was some interesting data that we produced off of that. One of the other stories I would like to spend a little bit of time today talking about was of one particular core. So in this process of going through and taking these cores out, an interesting thing occurred. And this was actually in the hangar. So Josh mentioned that this occurred at L-17, and this bridge has a suspended span. There's 450 feet over the river. That's a suspended span held up by hangars, large structural members on each side of the bridge there. And those hangars have about 5 million pounds in them to holding this thing up. And while they took the core out of the cover plate for this big box section that's the hangar, there was a notch noted, or a crack indication noted after the core came out. And talking to people, we went through and we looked at it, we tried to take some pictures, you can see a little bit of it there. And so there was an immediate concern. All right, why did this little notch occur? Why did this crack occur in the steel? Was this overly brittle? Is this thing going to propagate? Do we have additional issues from this fire that we don't understand? The people that are doing the drilling have done this many, many times over, a career, and they've never had a notch or a crack pop out of this. Still not sure exactly what happened here, but it was of major concern to us when this happened. And it caused us to say, are we in danger of having this entire hangar fracture or some other thing occurring here that we need to be more cautious of? And then we actually went back and shut river traffic down, kind of on an account that we could drop this suspended span if this hangar were to fracture. So again, showing this picture that Josh showed before, you'll see that there's that suspended span in the middle of the river, right? The heat effect on the fire occurred right in the middle of this thing. And the concern was that suspended span would be falling. It's a simple span portion part of the construction. If cantilevers built out from the sides in the original construction, you put that suspended span in the middle. So what we did is we took these steel cores and they ended up making a steel puck. So we brought them back down to Louisville here in Louisville. There's a testing facility here. They cut small slivers of that steel out and made a puck that was, about 1 inch diameter puck. There's a black medium of plastic that goes in there. They polish this thing down. The polishing process was pretty fascinating. Actually, when they grind and polish this thing down to the microns, they actually have a polishing cloth, but the liquid that they drop in there has different diameter diamond bits. So they'd have like a 3 micron diamonds in this thing, and they would sit there and rub this thing with a solution that had 3 micron diamonds suspended in it. Then they cleaned it all up, and they finally got down to a 1 micron diamond bits, but diamond dust essentially in this solution, and grind this thing down to a glass finish and put it underneath the microscope. So when they put it under the microscope, what you see in that right picture there, the dark portion is a mounting medium. The light portion of it there is the steel. It's very polished and bright. And you'll see a little bit of band. They were able to say, hey, there is still some paint on this sample. And what that essentially tells them is that the fire didn't get above that 1200 degree threshold. At some point there, that the fire would burn off the paint that was on the bridge. And since there was still a little sliver of paint, this section, I couldn't see the paint from the puck we took, but there was a little bit still left on there, at least to the metallurgists or those people doing it, giving an indication of the temperature that the fire got to and portion of this. The next thing they were looking at, they put it under a microscope. The picture on the left here is a picture of the crystalline structure of the steel from that particular sample. And what you'll notice there is that in general, it's kind of globular, if you will. The specks are still round and square, and that's kind of the steel section. The formation of martensite, when you elevate it and actually quench steel, the crystalline structure of the steel changes, and it looks more like you see on the right side. It looks more fractured, more like needles. I don't know these things, and I was there in the room, and one of the experts from FHWA was there as well. And when the technician pulled up this picture on the left, he just breathed this big sigh of relief. Oh, thank goodness. And I said, what's that mean? He goes, we're in good shape. So everybody that knew what they're talking about was happy about this and said, oh, we didn't have a change in steel. The structural properties haven't changed, and we shouldn't have a concern. At that point, we were happy. We could then go back through and report up the chain that whatever that little notch or indication was an an anomaly. They went and cleaned it up. We do not have a concern that they have changed the properties of the structure, and they could reopen it to river traffic. Again, there's as much commerce running underneath this bridge as there is running over top the bridge, which is a major concern for all those parties involved. So that was kind of that story of the steel and how that occurred. In the end, we did not have martensite form. There was no evidence of the structure altered due to the excessive heat. And so the project was able to kind of progress forward from the inspection side of things and saying, hey, this is where we're at, and we should be able to move on. A couple of pictures. These are the people going through, taking some of these steel cores on the left, and then down there at the bottom, we try to find cover plates and other non-structural areas to take our destructive testing. You see some of the concrete prep. That upper right picture is actually the laser spectrometer, where he just holds it up there, shoots it, and it gives him a chemical readout of the steel that he's looking at there. So it's a pretty quick process once we got the NDT team on site, and they could do quite a few locations in a short period. Want to move on here to design. The next part of this thing. So within the design side, we had to rely on the inspection team to provide information. What is the extent of damage? What needs to be replaced? What is the scope of this project? And then from that, can you provide the details that we need in order to do those repair plans? So as you can see, this bottom left, that kind of shows a picture with the water coming through it, as Josh said. I mean, it just kind of rained through the deck. We knew we had to replace it. The stringers were greatly distorted. The finger joints down there in that bottom right picture were offset. The fire occurred again at a joint location there and needed to be reset. The concrete on the top there, top right, is the deck. On that lower deck, you see it just pot marked everywhere. So the design process required a lot of coordination. There's a lot of meetings and calls between the field and the office. Hey, can you go check to see what the plans say this, what is the field showing? But we essentially said, if it isn't broke, don't fix it. Let's use the existing plans. In these type of situations, the best thing to do, pull out those old plans, pull out the shop drawings. Let's annotate that stuff. Palmer Engineering had done a previous project to do some replacement on the joints. So they took charge of all the joint replacement and joint portions of this project. And were able to take portions of that project that was ready to go to construction and roll it into the project to replace those areas and things that needed to be fixed on this project. And that worked out really well. So we did create a few new sheets. We marked up existing sheets, existing shop drawings, running all that in parallel, trying to get that to come through. I like this picture of one of the electrical plans. This is actually, picture here is actually a sheet that came out of it. And what you see here in the bottom right is a picture that our inspector took in the field with notes annotated on it. The other portion is the original plan of what's supposed to be there, and that's what was provided to the contractors. Say, hey, this is what should have been here. This is what you're seeing in the field. This is the portions that need to be replaced. This is the damaged stuff, and that sort of thing. The electrical portion of this actually was a good indicator because it had lights on that lower deck all the way down through the bridge. Those are plastic fixtures, so you could very quickly and during the inspection tell, hey, the fire got hot enough to melt the plastic at these sets of lights, but that light down there is not melted. So we can kind of start limiting what is the temperature. And not only is it the paint has been removed, but what is the plastic on these lights doing? How far is the conduit? How much of this electrical stuff was damaged? Again, giving us an indication of the extent of our scope and of the project. The shop drawings, similarly, we took the old shop drawings and said, hey, fabricator, use these shop drawings. We need a new stringer. Here's the original one. You know, these guys and, old guys drawing this stuff by hand knew what they were doing. They made great shop drawings and it worked out really well to kind of highlight, this is of these big, massive old shop drawings. Use these sheets. Here's some additional notes. Here's the paint quantities and the painting that needs to be done, etc. Let's replace this and kind of move forward. So I mentioned the hangar, right? So we had the hangar that had that crack in it. One of the first things that happened while we were running around trying to figure out whether the steel had changed was to find out how critical is this hangar. So the picture there on the right is the actual hangar. It's a box section, right? It's got 6 structural plates, 3 plates on the inside and outside of that, and then the cover plates, perforated cover plates that make up that box. And so we went through an analysis to look at the internal redundancy of it. Recently, within the last 2 or 3 years, AASHTO has new redundancy guidelines. The AASHTO guide specification for internal redundancy of mechanically fastened, built up steel members is the publication. And so what we did is we said, let's suppose one of these 6 structural plates cracks and breaks. Can the other 5 handle the loads from this? So again, because of the speed of the project, we didn't have a full models and understanding of the exact loading of this. We had the original loading, which allowed for, which was provided. And given the original load, the member was internally redundant. Now we scaled up this to look at the original bridge had 3 lanes of traffic in the upper and lower deck that has since been increased to 4 lanes of traffic in the upper and lower deck, which does increase the live load some. So we made some estimations, but in the end, we felt that this was still an internally redundant member, removing the worst case scenario. And therefore, again, it provided some additional comfort to us in making those decisions. Can we open this to vehicular traffic? Can we open it to barge traffic? Part of the process that we used for this bridge to get it open. Again, document control was an important part of this. We were producing plans about every 12 hours and providing them to KYTC about 7 in the morning and 7 at night and documenting these things. Again, in order to have this done in 5 days, the contractor showed up on Saturday afternoon. We gave them a presentation of the scope of work, and they were supposed to have bids on Monday morning. That ended up being at noon on Monday, but the contractors had a very limited time. So we were providing updated plans to those contractors and to the state, but we were still in the process of trying to develop what you saw, they develop these plans and get those to those things. Once it went into construction, we said, hey, we're going to make sure we do all these submittals, turn them around in 24 hours, whether that's the shop drawing reviews or the other things. But when these fast track projects, you've got to be able to track it. You can't have things falling through the cracks. So we had our spreadsheet, but we tracked every submittal coming in and out, our RFIs coming in and out, and turned those around as quickly as we could. So if the contractor had questions, we were answering them, and that way we made sure nothing fell through the cracks. That the inspectors in the field and the KYTC personnel in the field knew what the status of each submittal was, of each question was, and then what the resolution was, and we could track that for them. So that's the major part of the project, and I'm going to go through the rest of this. Some of you have seen a lot of this presentation. I will go through the rest of this fast because of time. Josh and I did want to focus more today on the more technical sides of the inspection and design, but I do feel like it wouldn't be a complete presentation unless we at least ran through the rest of the story. The procurement portion of it, we went through here and got some steel purchased the Friday after the fire occurred on Wednesday. So 2 days later, KYTC purchased some stringers, knowing that we would need them, not knowing how many, but also not wanting that steel to go away because we had to wait for the rolling schedule. We were months out, and there was some available at some of the yards. So they went ahead and pre-purchased steel even before the contractor was on board. The Cosing Construction was a low bidder at a little over $3 million. And they submitted that on Monday at noon. And we had our pre-construction meeting that afternoon and got started. The MOT, they mentioned that being a major component of this thing. And it was, right? This is 160,000 vehicles that have to be detoured around, a downtown urban area. And so Kentucky took that burden off of the contractor. Cosing was not responsive for MOT. Kentucky took care of it for the Kentucky side of the bridge. ODOT took care of it for the Ohio side, and the states maintained and ran this. They modified it as they went to meet the concerns of the local officials, and took in a lot of comments from the general public in order to try to optimize this. As it got to snow and ice season, they modified it to try to make sure that their snow and ice removal accounted for the fact that they could not have any of these or the shoulders closed so that the emergency vehicles had additional things. Did a really remarkable job on that part of the project. Again, moving on through it just due to time. Public awareness was another big part of this project that just really went above and beyond their needs here. They had a dedicated website. But really what I want to say about public law, they focused on the people, right? There's the nuts and bolts of these projects that us as engineers like to talk about, but it's the people that the public connects with. And KYTC did a really good job in this thing, focusing on the people doing the work and what had to be done, and telling the story from their standpoint and through their eyes. And the people really connected with that, I think, and it worked out really, really well. The construction, again, the construction happened not complicated, but it happened in a complicated situation, right? We just had the COVID, we've got to have extremely tight time schedules and the weather. They worked through those things, to come through this. They took off the upper deck of it. They replaced our stringers, formed it all back up and placed your concrete up there. They removed the overlay on the bottom deck, fixed the barriers where the trucks had crashed into them and the fire had occurred, and were able to open it back up. So that was quickly the scope of it and what we had to deal with on it. They did some additional efficiency projects while the bridge was closed down, and that worked out very well for KYTC and all those involved, and opened it one day early. So in the end, it took a lot of leadership, communication, and teamwork to make that happen. I like this quote: never tell people how to do things, tell them what to do, and they'll surprise you with their ingenuity. And I think, as Josh mentioned, everybody jumped in on this project and asked, how can we help and how can we get this done? And it happened, right? So at the executive level, it was mentioned in the video, we had to open this bridge quickly but safely. The leadership at the top levels made the goal of this project, knew exactly what we wanted. Everybody stayed focused on that goal, and it had to happen. And from a company standpoint, right, anytime you say yes to one thing, you say no to everything else. And so in order for a company to say yes to this project, you have to say no to other things that you were doing in your life and in your work. And so you have to have leaders that can say, I will make sure that this other stuff gets done. We will clear your schedule. You're focused on this important project. And that happened across the board for everybody involved. So I think that's helpful. We'll move on through this as quickly as I can. But again, communication was important. Josh talked about himself being on meetings all day long for his stuff, because that's just, critical and needs to keep everybody informed up and down the chain, and to make sure those happens. Regular meetings by discipline and leads. Again, so in the end of this thing, we did finish this ahead of schedule and a budget, and with overwhelming positive support. I know, talking to several people at KYTC, they said normally the only thing, feedback they get from the public is negative, and why didn't you do this? This is bad for my day, you closed it down or whatever. We did get a lot of really positive support, and that made everybody on the project pretty pleased with it. I think these slides will be available, a timeline, if you're interested in it, you can pull that off there and kind of look through that timeline. But in the end, just want to say thank you to KYTC, Ohio Department of Transportation, for their benefits in this. I mentioned FHWA had sent some technical advisors down that were instrumental in those initial phases. A whole team of consultants and contractors that worked tirelessly to make this happen. And it would not have happened without everybody's effort on it. And I want to appreciate and say thank you to all those involved. So in the end, I'll ask if there's any questions. Probably don't have a ton of time, but if there's any questions, please let us know. Look online, they have that ability to ask questions. They hadn't tell me that. If you're online, you're asking questions. Yeah. All right. Thank you all very much. Appreciate your time today. I see there's some detail here.